All right, Lady Ada, what is this?
Hey, everybody, and welcome to Show and Tell. Me, Lady Ada, with me, Mr. Lady Ada. But right now, we're going to check in with people from around the making, hacking, coding, software, and sewing, and more community, see what you're up to. You making stuff? Come on by. We're in StreamYard. We're on Discord. We're going to be here for the
links in the Discord chat to join, and this also gives you a special preview of some of the behind-the-scenes activity and more.
What are Adafruiters doing?
The Adafruit team's doing. So speaking of, let's start with Scott. Scott, what you got going on?
Hello. Thanks for having me. Thanks for starting with me, too. I forgot to ask you that. So I was at the Zephyr Dev Summit last week, which is like a bunch of Zephyr people get together. It's hosted by the Linux Foundation, so it's a lot of embedded Linux-y sorts of folks as well. And some of the folks that were there work at Ant Micro, and they have this open source project called Renode, which is an emulator for like microcontroller class devices. And Zephyr is using them to test kind of in the cloud as well. So I wanted to get CircuitPython running under this because it makes information about how code is executing way more accessible than if it's on the device. So there's a PR out for a new port of CircuitPython called Renode, and I just wanted to show CircuitPython running in there. So I'm going to run Renode. And the -P starts it on a particular port. And then I'm going to telnet to that port so I can tell the emulator what to do. This is a script file, Renode script file. So that sets up like what sort of CPU and loads the code into the emulator. And it also loads a CircuitPy file system. That make generates for me based on a directory. So if I just hit start here or type start, and then this bottom window is TO connected to the virtual UART of the emulator. So my code.py is this hello from Renode. And if I just enter, I can interact with it again as well. So that's CircuitPython running on a virtual Cortex M0 Plus under Renode.
So is the idea here that you want to eventually make it so any emulatable Zephyr chip could have CircuitPython ready to go for it? Like you wouldn't have to do the beginnings of the port? Or like,
so my goal was to like have the system be the same, but be able to swap different CPUs in potentially. So like having, like this is a Cortex M0 Plus board, but we could also have a Cortex M4 board as well.
Yeah.
And then it would run the emulation on the M4 with a different like compilation stuff instead.
Okay.
To kind of like I did try to run it on the like actual board definitions that they have for these things. So like a virtual SAMD21. But the problem is that we use a lot of different peripherals. And if you access a register that isn't supported by the register, it'll just log. And then like it'll log and like return 0. So if your code is just like waiting for some bit to be set, it'll like never be set.
Yeah, you're like, oh, I'm going to write to like 4008, which is supposed to be GPR or register A, and it's not there.
Right.
Okay, so it doesn't. So Renode does not have any hardware peripherals, and it's just like the CPU.
In this setup, but that's not in their world. They actually do want to model the whole SoC, but we use stuff that has not been added yet. So like in particular, the flash controller. So like being able to like manipulate virtually the internal flash is something we couldn't do on like this STM or the SAMDs. So we could add models for those missing peripherals that we use to make it work. But I decided to go this other route because I don't really care to pretend that I'm on these other things. I only need this like as a harness into like the VM on different CPUs.
Yeah.
So you can do tracing, and actually if we have, I don't know how many more people showed up, but if I switch screens, I also have a browser window. So this is an execution trace that I took from the emulator. So this is kind of a flame graph of what functions call what when you're running a code.py.
Yeah, they're pretty handy.
Yeah, and the nice thing is that I can look at it without kind of having to figure out how to do this on a device. So like,
Yeah.
here's loading it from the file, and this is how long it took, or how many. It's not really how long; it's how many instructions. But like parsing the file took this long.
It's a good gauge of like what is taking up time.
Right, exactly. It's still a reasonable gauge for like what we would need to like optimize if we wanted it to run
I think like if you're doing like heap optimization or like compressing strings or I'm like, okay, is that actually saving me time? You wouldn't have on here, you wouldn't have to run it.
Right. So the thing that I was just thinking about adding was like the ability to monitor like VM heap usage. So like being able to have a little graph that goes along with this to show me like how much of the VM I'm using. Because one thing in theory we could do with this is measure how big libraries are once they're loaded in memory. So like automatically in CI being able to like,
oh, that's handy.
Load it up, like make a code.py that just does import, DHT or whatever, right? And then we can instrument it using this, and we can just say, here's how much space it took.
Yeah.
And we can track it over time.
Yeah.
Just because we've had this problem where, like you work on a library on an ESP and you make it bigger and bigger and bigger, and then it no longer runs on a SAMD21, for example.
Interesting. All right.
All right, cool.
Yeah.
Cool.
All right, thanks so much, Scott.
Thanks for having me.
And you'll be diving into some of this maybe on Friday?
Yeah, I plan on it. Yep. So if you want to know more, deep dive, 2 p.m. Pacific here on the Adafruit streams.
Yeah. So if folks are interested in this, come on by on Friday, 3 p.m. Pacific.
Yep.
Okay.
Okay. Jeff, what you got going on?
Oh, you're muted. So hit your mute button.
Beep, 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 beep.
Okay. I was excited to hear about what Scott's working on, but I'll tell you what I've been working on, and that is this Z80 computer from a long time ago. That's actually the drive enclosure. But I made this passive board that connects it to a floppy emulator known as GoTech. And I was just writing up an Adafruit Playground article about it because it works. The other day, I successfully booted from a virtual floppy into CPM on this thing. So
nice.
It's just kind of a passive adapter. This is not really set up to see it, but it just wires through all of the pins from their custom 37-pin connector onto the more standard 34-pin. Is it Shugart style connector? And then you got to put some configuration files and an image file, but it works. And I'm really excited because that thing makes an unholy racket when it's running. I don't know if you've been around 8-inch floppies, but they are loud.
Zeep, donk.
Yeah. Well, even just the motors, which spin constantly, they didn't have the ability to stop the motor when the drive was not actively being accessed.
Yeah.
So both of those motors just spin all the time.
Like another decade.
they're like clothes washer motors or something. They're powerful and loud. But so that completes the 3 things that I needed: the keyboard, the display, and the floppy drive, so that I can just use these bare boards that I got at the estate sale a couple years ago.
You're ready to Z80 it up.
I'm ready to Z80. Now I just need something to, do, but I can play some Zork or some Trek or all those fun classic text games.
That's so cool. Okay. Thanks to the power of CircuitPython and circuit boards.
Yeah. CircuitPython, open source, a little bit of Arduino, but don't tell anybody. And yeah, it's just, it all comes together to make classic hardware work again.
I love it. It's cool. It's like near ancient technology, but we have open source hardware that can bring it back to life. Which is the topic of your talk at PyCon. So everyone going to PyCon.
Yeah, that's right. Sometime next month, the schedule's online. I'll be giving a talk about adapting like old keyboards and mice to modern computers via USB and CircuitPython. So got to get to work on that talk at some point. But I know what I'm talking about.
Well, you're gonna write your slides on the Z80.
I'm gonna write my slides. I don't think so. Don't tempt me.
Click.
Don't tempt me. You're the evil devil.
Yeah.
Which shoulder does the devil sit on?
There would be
the left one, isn't it?
I'm not saying you should, but it would be really bitching if you came in and just you just did your entire, because you have the HDMI output.
That's true.
The Xerox 20, and you just rolled in, and
just
you're
plug it in.
Hey, where's the AV? Xerox 820. Classic. Okay.
All right,
y'all.
Okay.
I don't think I would take that point. Okay, next up is
is JP. What you got going on?
Hey, I also just want to suggest that Jepler write it on the plane on the Z80 on the way to the conference. That's always the way.
Like a little like the tray is like sinking.
Yeah. Pardon me. The power plug.
One cool thing about New York is if you go around to different Starbucks, eventually you find someone with a desktop computer.
We have seen people with desktops and CRTs in a Starbucks.
It's great.
And like in the last 2 years.
It's great.
Like they'll bring their 19-inch CRT and their desktop and they just plug it right in and they're like,
it is
click.
That's so great.
Yeah.
And we're like, this is great.
Okay, cool.
All right, JP, what you got going on?
So speaking of adapting old tech, my project I've been working on for a couple weeks now. I just finished the Learn guide for this, and it's up is the original Sony PlayStation controller, which I've put a ESP32 Itsy Bitsy in. So it's now a Bluetooth controller. And one of the fun things I learned along the way was how to put it into deep sleep mode, how to measure what I was actually drawing current-wise, because this is running off of a little LiPo battery, and make some changes to fix the whole thing. So Limor said, hey, you can actually profile with this power profile kit from Nordic, these really, really small currents and really precisely, because a multimeter really wouldn't do you much good in this case. So when this thing was in sleep mode, I was getting 1.8 milliamp draw. The way I knew that was that this was powering this instead of the battery. And I'm just going to switch my screen share real quick here so that I can show you a page from the guide. So Limor said, hey, write up an extra page on your guide here that explains what the heck you did here. So that is the software that this power profiler comes with from Nordic. And when I am powering my controller using that, this active section that's mostly all the same, around 125 milliamps. That's it in use with both the radios on, because there's a Wi-Fi and a Bluetooth radio that are running. And then when I was in deep sleep mode, it was this not so deep sleep that was about 1.8 milliamps. And that would give me about 8 days of idle of this sitting here, of the battery sort of slowly discharging with it mostly not in use, which is okay, but we're kind of used to a deeper sleep than that from these devices. Most LiPo things you pick up around your house can go months and months without dying on you. So when I dug into this and started messing with what I was running in code and looking online, I eventually found out that not only does the ESP deep sleep start command need to be issued to set it into this sleepy mode, but I also needed to explicitly turn off the Wi-Fi radio. For some reason, that's not really bundled up with the deep sleep. It may be because I'm actually
except for Wi-Fi activity or something. I don't know.
Yeah, there's probably more to learn about why it's that way. I didn't find that part out, but I did find out that it works, which is kind of what I cared about the most. So once I started doing that, we got this graph here, which it's going to probably be hard to read, but this is essentially 0.07 milliamp versus 1.8 milliamp. So huge difference when it was in sleep. And that's this little section that I've selected over here, which thanks to the handy dandy DigiKey battery estimator, which is awesome. And I think I put a link in the guide to it. I can tell it, hey, I have a 350 milliamp hour battery. I am running at 0.077 milliamp draw, and it says super. You've got 6 months of it sitting there.
Yeah.
1 week, 2 days, 2 hours, and 27 minutes. You'll be fine. And
I think also, by the way, the Nordic PPK can do that too. You can tell it what battery, but it's like it's a weird, complicated thing. It's not as easy as like the DigiKey one.
Yeah, the DigiKey one was.
If we find that, though, maybe ping us. Maybe we'll put it in the guide.
Yeah.
So
there it is. That's it running. And last thing I'll say is this thing has really cool LEDs. When you flip it on, you'll see it gets a little light show here.
Yeah.
They've got these two windowed LEDs.
Nice.
So it's got some color coding when you're using it for different things. It can supply power and data. So
pretty cool.
Yeah, I love it. I use mine all the time. That's why I was like, go get one, because I was like, this is a really good idea for you to use. Because if you're going to do low power stuff, I feel like showing people how you verify it is important, because otherwise people are like, how long does it last? I don't know.
Right.
It's like, you got to get
I would have had it way wrong if I thought it was really in deep sleep, because the numbers on like the Espressif site said you'd be down around, 0.03 and I'd be great. I was nowhere near that. And so
Yeah. But how would you know? You're going to wait eight days?
Right. And then find out. Yeah. And well, you were saying that these comparable devices used to be many hundreds of dollars.
Yeah, I have one. They were $800 or more. They used to be very expensive, and now they're under $100 or $99, which is great.
Thanks.
And also now because of competition, like I think ST has one. Like there's a couple other companies that make their own because they're like, oh, this is really useful.
Yep.
Because they're all selling low power electronics.
Yeah. All right. Well, so I'm going to be doing some of my more arcade joystick stuff tomorrow, and maybe getting that giant thing to be wireless. We'll see how that goes. So, got some more joystick.
We might show a clip of that video on Ask an Engineer tonight.
All right.
Thanks, JP. All right. Next up is Ann. We'll go to Tim and then to Chris. Ann, what you got going on?
Well, I have a lot of parts. Being a woman of a certain age. Actually, I was trying to work on this PCXT. I let the magic smoke out and a bunch of stuff didn't work anymore. I needed a way of testing the RAM chips. And there are chip testers out there, various kinds. I never saw anything I really liked until I saw one from a company called backbit.io. It's called the Chip Tester Pro.
That's cool.
Picked it up. Pro. It was only like a couple $100 compared to some that are more expensive. And what I did here is I have a vintage Z80 microprocessor, and I turn it on. So it has this nice display that shows you can select what chip you want, and you have it, and you press that, and it says press test, and test the chip, and green. So my Z80 is working, so I can fix that. I don't just have that one chip, but a while back I was dumpster diving, and I got a hold of a lot of chips.
Oh, wow.
Yeah.
Cool. I love the gold. And more chips, and finally a few more chips. Actually, if you all want to stock the 7475B I think it's a flip-flop. I've got like 300 or something. You have to start animatronics.
I don't know. It's just real fun. I mean, I used to build a lot of microprocessor computer systems in college and stuff, and it's fun to be able to test some of these chips to make sure they're still working. It won't be, it'll fit a 40-pin dip okay. I've got a 68,000 engineering sample. That's too big. It will not fit. So no, I'm having a lot of fun. It's not too expensive. We talk about test equipment, and they have a lot of chip profiles, and it's a cool little device. So if you're looking for one, backbit.io.
Okay.
Thanks so much. And and if you can post the link in one of the chats too, if anyone needs it as well.
Will do.
All right, thanks. All right, we're going to go to Tim, and then we're going to go to Chris. Tim.
Hello.
Good to see you.
For anybody that doesn't know about CircUp, CircUp is a command line tool that lets you install CircuitPython libraries on your device. But the new thing that I want to show you about today is a brand new command that's inside of CircUp that was just released. It's in the latest version 1.8, which is helping you install examples on your device. So you can now say CircUp example, and then you can list like whatever library you want. So let's say if we want maybe an NTP example, and it supports tab complete too. So I can kind of just hammer on tab.
Because you're like, I don't even know the example. What are they? Like
exactly.
What about NeoPixel examples? What NeoPixel examples you got?
Yep. So you can tab complete those. It will load it up for you. I have my just whatever device was on my my desk over here. So we put NTP. We loaded that one. But yeah, you can do any of them. Whoops, CircUp example. You can do any library. Whoops. For example, Neo. Oh, there's more than one Neo, maybe. Yeah, there's a Neo Trellis. So we can say NeoPixel.
NeoPixel, and then maybe the Rainbow IO simple test.
Yeah.
That's a good one.
So you do that. Okay, so
I could use this every day. This is amazing.
yeah, I think this, and I did some work in the build tools in order to make this possible. So now we bundle all the examples into subfolders inside the bundle. That was kind of the stuff underneath the hood that make this work. So I was super excited to get this inside CircUp. And then the next thing I want to show, which is not part of CircUp, but it is related and it uses the CircUp, is another tool that I've been working on, which is a TUI terminal user interface. So this is still in the terminal, but it's much more visual here. There's actually a big old list of all the libraries. You can scroll through them. You can unfold them, and then you can just click on whichever one you want, and it will actually load that one on the device. But if you do want to go, search style, you can do it in the top there, search, and you get the same list. You can also, if you press enter there, then you can kind of start arrowing and doing all that sort of stuff. And it just
totally
loads
reminds me
the
of
same
like
volume.
every Linux application I had running in like 1998, like in a good way.
Yeah. This TUI thing, this was the first time I played with it. I think it's called Textual is the Python library. So that was really cool. I think Jeff or somebody played with that a little while back and mentioned it during the meeting, and I kind of threw it in my list of stuff to look at one of these days.
But it's like so clear, you know what I mean? Like why do anything more complicated? This is straightforward.
Yeah, totally. So that's all I have for tonight. New stuff on CircUp, and then this one is not out there yet anywhere, but I'll get it up on GitHub in the next couple of days or so.
Love it.
All right.
All right.
Thanks,
Oh, I'm so excited.
It's very
This
cool.
is good. Keep coming by with updates to these tools, because I didn't know, now I know about this. I'm definitely going to use it because I'm constantly loading examples to just get my hardware up and running. I'm like, okay, let's do the SD example, NeoPixel example, the TFT example, and this will save me a lot of time.
Yep. I'm only starting from the examples as well, so I'm in the same boat.
Right on. Okay.
See ya.
All
So
right.
much, Jim. All right, Chris, play us out. What you got going on?
Hey, Chris, unmute. Okay.
I know, I'm unmuting. Can you hear me?
Yeah.
Okay, so I'm kind of new here. My hobby is making cosplay props with 3D printing and DIY electronics. And what I have to show today is,
Oh.
Very cool.
yes, this is a replica.
It looks so bitchin'.
This is a replica of the necrochasm from the Destiny franchise. Here,
I
let me
was
turn it on for you.
I was like, that's totally got necrochasm all over it. No, I don't know, but it's death looking for sure.
This is cool.
Oh,
nice.
LEDs. Nice.
The reason why I wanted to show this in particular is I'm using the prop maker feather. Your Adafruit prop maker RP 2040. Yeah.
That's what it was made
I'm
for.
glad. This is exactly
Yeah.
what I was thinking when I was designing the board. I was like, I hope somebody makes a necrocaster out of this.
That's cool. And
Well,
so the LEDs are embedded in the little teeth-looking things on the side.
Yeah, that's nice.
They're actually flames, and if all it did was light up, this would be a very short video. But I loaded this with a bunch of features, so
Okay, sure.
All right, what does it do?
the trigger actually works. So it makes a firing sound when I pull it, and
Okay.
I'm firing virtual ammo. So the ammo counter is right here on the cartridge. Watch those LEDs.
Oh yeah.
Oh, yeah.
Ooh, and I can hear it. Nice.
Yep.
Okay, now
Yep,
I gotta
I re-
reload.
Yeah. And the way I reload is very cool. I can actually take out the cartridge.
Oh.
Ooh. Oh,
See?
look at those magnetic connectors. Nice.
Yep, I used a 5-pin magnetic connector. 3 of the pins is for extending the LED strip. 1 of the pins is for charging because I can actually charge this through USB-C.
Yeah.
And the last pin is for reloading. I'm grounding a pin, so when the cartridge is out, the pin is open.
Yeah, then it's reloaded. Oh, yeah.
Nice. Smart.
That was actually one of my easier ideas. One of the things I can't show very well in this video is this prop actually rumbles.
Oh, cool.
I know you designed the RP 2040 for servo motors, but in order to make this thing rumble as it fires, I actually used a DC motor driver.
Huh. No, that's great. I mean, you've got plenty
That'll
of
work.
pins. Wow, this is so cool. Is this for like a full like costume, or is it like you just make the prop weapon itself?
Well, originally I wanted to make the prop just for the sake of it, but I plan on doing like a full costume to accompany this.
Okay, nice. Well, I
This is like an infomercial for the prop wing.
I
Yeah, it's just
know,
like,
this is so cool.
but wait, there's more. But wait, there's more. But wait, there's more.
I would love if you posted some photos or video on the Adafruit Playground if you can, or if you want to, because I think people could learn a lot. Like I can see you put a lot of thought into this prop.
Yeah, use all parts of the prop maker.
You can thank my father because he recommended I document the entire process. I take a bunch of pictures of assembling this.
Oh, nice.
But where exactly do I go? Is it like a Discord channel?
Yeah, you can go to learn.adafruit.com and then check out the playground link if you want to post it
at the top.
Post them online.
Playground, and then you can make it. It's like an ad-free place for people who you don't have to use Adafruit stuff, but like a lot of people who do. We're like, I don't want to put my stuff on a site that has ads and like place, like newsletters. So you can just put your photos up and then share them, and then other people can learn from it, or it'll just stay there forever.
Yeah.
Well, thanks for the advice.
Okay. Or post it in Discord too. I mean, like we have
Yeah.
a Discord, and people are like, "This is so cool! Please share it." They're asking to see what you did.
You now have an instant fan club. So
Yeah.
check out the chat in Discord. Good work.
Yes,
Chris.
I'm reading the chat right now. I appreciate the comments. Thank you
Yeah.
all very much.
Good work. Yeah.
All right, awesome! What a great.
Thank you so
way
much,
out.
Chris.
All right, thanks for coming by, and come back with more props as you build them, of course.
Oh, I sure will.
Okay. Bye-bye.
All right.
All right, sweet. Finished just on time. It's
way to end the show and tell. That was a
7:57.
fantastic prop. What's interesting is the prop maker, there wasn't anything like it. And we're like, well, there's so many projects that can't be made yet. We don't know all the projects, but once we get it out there, we'll see surprises. And that was a big surprise. That's really good.
I'm so glad that people are doing exactly what I hope people would do.
Yeah.
All right.
All right. Well, that's our show tonight. Thank you, everybody. Thanks for
gotta
making
get
this the best
ready.
half an hour of the week, every single week for us.
Yeah.
Show and tells every Wednesday, 7:30 p.m. Eastern time. Come on by. We're here every week. So if you miss this week, it's okay. Come by next week. We'll see everybody soon. Ask an Engineer starts in just a few minutes.
Bye.